All right, so I just wanted to start by showing what is the current problem that we have in metals. For example, we have two files, and one can reference a value from another one. There's no issue. Completions, everything should work. But if you add maybe this other value, like on the right, that is supposed to be a string, but we declare it as an int, so that's an error, metals will not be able to show you that other value as a completion, despite really in the first file, in the main, we don't care about whether the other value is well implemented. We might want to do that in a while. We might want to fix it in a bit. Maybe it's an error that's related to some other changes, and we're doing a lot of changes at the same time, which a lot of the time breaks the code. So, but we have a type, so we should be able to just use that. And currently, it's not possible. Why is that? So the way it works that we currently use the class path as given to us by the build tool via BSP. So each time you save a file, it gets compiled, and then the presentation compiler gets that class path and use the information from that class path to provide basically everything. For example, completions, for hovers, everything. And if that data is not compiled, so we'll have an old view of what's going on. This helps us to avoid like a double completion, because otherwise we would need to, each time you save file, we would need to have compile every file using the BSP and every file using the presentation compiler. But it helps us in that case. But if you're working on multiple files, as you've seen previously, there is a big issue, and it's not an uncommon scenario to have to be working on a broken workspace, especially when refactoring things that not necessarily are supported by any kind of IDE, because you sometimes want to add a value, a parameter, and there's currently no option to automatically add a parameter. Maybe that could be a good refactor thing, but currently there's nothing like that. So it's not an uncommon scenario. But so to avoid that, we would need to compile it again, compile maybe all the files in a single module, maybe all in the whole workspace, maybe have a limit of files that we follow. But this will cause the completions that we would not only completions, but that's an example, but they would not be fast and would be much more annoying to work on your code. What we can try to use is the Y outline compiler option. So this, what it does, it will not try to compile the entire bodies of right-hand sides. And we can get like a basic outline signatures from that, which can be used by other files. So this is, I think, used by Zinc for pipelining compilation, because if we get all the public signatures, then we're able to see if any of the signatures have changed, and maybe if we have to recompile any of the downstream files or downstream modules. In case the signatures didn't change, nothing really needs to be done. But if the signatures changed, everything needs to be recompiled, and we also want to see that result when working in the IDE. So one would be try to the Y outline option, and that should be much faster. We would, because we would only need to type check the most basic signature that we get. We wouldn't need to type to everything in the bodies. And from what I've seen, I don't have the exact timings handy, but this usually in the compiler timeline, it's a short time at the start, and it can really we can really use that much that speed up to just get all the symbols that we want. Another thing, maybe we could only try and see if there's any broken files that didn't compile. Maybe for those files, we could get compile them using Y outlines, and only that would probably be much more complicated, because maybe other files didn't compile because this one didn't compile. So it's not perfect. Maybe if we only allowed for broken files to be in the same module, maybe that would also minimize the issues. But on the other hand, there's workspaces in some mono repos that are using very small modules, and so that would not be very helpful for them, I feel. So there's some possibilities. The main one being with outline compilation, but there's a lot of problems because, as I said, with the files, if we want to keep the most recent view of the workspace, what symbols are currently, what were removed, what are added, then it's very hard to figure out which ones we need to compile, and probably we need to compile every single one, at least with the outlines. So that can still be a lot of files. So we could try something like zinc. So on every change, try to figure out what else we need to update. So we would have this cache of symbols, and on each signature change, we could try and refresh the views for all the other files. But that is the complexity of Zinc. Maybe we could actually use Zinc for that, but not 100% sure if this would not be a very dangerous rabbit hole that we could spend months in and not end up with anything. We could probably start with a prototype type, so maybe I'm just having black thoughts here, but anyway, if we're talking about Scala 3, for example, there's no Y outline option currently. So maybe we could figure out something new. So we've been thinking maybe we could add a similar option to Y outline, that we could say to the compiler, could you dump the signatures into this other directory, and metals could read from those signatures, and even if that option could, for example, try its best to compile everything and dump all the signatures. So even if the file is not fully compiling, it might work. Not so it's also not that easy to do, but we can try something like that. That would require adding a similar flag that we do add for semantic DB, but we already have workflow for that. So that would be just adding this new flag and saying where metals expected, and metals could just get that. So maybe that is a new option is an option, maybe. Or maybe if we manage to get Y outline working with Scala 2, then it would be easier to actually implement white outlines for Scala 3 and use that. So maybe a lot of maybes here. But I managed to actually do a quick demo, so I can actually show that. If I make it much bigger. On the right-hand side, we see a lot of debug information. but if we close everything that is not really, let's make it a bit bigger. So we have this main file, and then we have this broken file that doesn't compile. And if you, for example, do B, then we get a foo, which is correct. And then let's do add foo2, and let's see, that might, it's not still working perfectly, and it's still and there's foo2. So it actually is working. It took me the morning, but it's like a very fast prototype, and I do recompile everything. If you look, this is my if I each time I actually write a letter. Oh no, it doesn't compile everything. Okay, never mind. But sometimes it's, oh yeah, now it recompiles again. So every time those logs go on, it means everything got recompiled. But that's because I just did it today. So, but so this is, and I'm also not sure if Y outlines is working. Maybe somebody is able to tell me if doing a thing like setting the option, then running the type check. This is the it's the global interactive, which is the presentation compiler. So this is the presentation compiler, and we're just using it here to type check, and then traversing everything, get the newest symbols. Ideally, if it's Y outline, we only traverse the top kind of nodes, and it shouldn't be that much effort. But I'm not sure if setting outline first true to true and then to false is a very mutable. But and it's, I haven't been able to notice if the actual tree is only partially typed or is it fully typed. But anyway, this is the whole thing. So what we do is we just have all the sources given. If it's a Scala source, we try to read it. Obviously, it should be totally different than it's currently, but it's like a very first step. And then we try to compile everything, traverse everything, and add those symbols. This is the visit member. So we inform metals about that particular symbol. There's a bunch of conditions here which are kind of experimented with it, and this finally worked. This is, but what we actually do here is only take the top symbols, and that seems to work. But yeah, so this is very much a prototype. But if anybody has any ideas on how to make it work better than what I explained, then I would be very welcome to get any feedback. We'll probably try to suggest some new improvements to Scala 3 or start a conversation there. I usually get a good response from Martin, and he has a lot of good ideas, and he might have some ideas that I never would have thought about. So maybe it can be an option to just start a conversation. For Scala 2, I don't think we want to change the compiler itself, because that is, there's much more already released versions of Scala. And this new approach, if we add a new flag, wouldn't work for any of the old ones. And for Scala 3, there's much less versions already released, and we could probably make it work reasonably soon if we focus on that. But the end for Scala 2, we do already have the Y outline option, so maybe we can experiment a bit more with that and see where we end up with. So that is my very short presentation of what's going on, what we would want to achieve. And I think that would be a game changer for a lot of people if we manage to make it work properly.
Mm-hmm.
Yeah. And in the what could go wrong section, I can certainly give you a bunch of ideas. One is, well, you can't even type check the signatures because the signature itself is wrong. Or there's a parse error that gets recovered in the completely wrong way.
Yeah, I mean, if the presentation compiler cannot deal with that, then we are lost, really. So the only code that is not compiling is the one that the presentation compiler would normally deal correctly with. But I feel like a lot of the times it's some type errors. Those shouldn't be an issue.
Is this more of a special mode, especially just for this one kind of use case of the editor providing a name for you on an autocomplete? Because I guess you want the name to be there even if the signature is totally wrong and doesn't even make sense.
Yeah, the problem is that the signature might be correct, but it can still not be shown if you wrote that signature in a file that is not compiling. So, for example, you wrote a new field to an already existing object, and that object has a very far away error somewhere, and we will not get the view of this new completely valid field.
Okay, yeah. So it's still useful for that.
Yeah, I think it's a good assumption to say the signature is good, because then you can have extension methods and implicit resolution working as well. If you don't have the signature, only the name, you can resolve the name, but then you're stuck. You can't do anything with it.
Yeah, that's a good point.
Yeah, so we need to have something that the presentation compiler can deal with.
So I guess what is the issue now is that normally if there's just one error, then the compiler will stop at the typo phase and then not get to the phase where it emits information.
Class files.
Okay. Yeah,
we don't get any class files.
Yeah. But what kind of format would you want these signatures in? Like a new custom format or?
No, I wouldn't. Like for Scala 2, there's already a possibility of using pickles, and that should be enough. And from what Vadim experimented with, it is possible to read from those and get all the proper thing. The only issue was that if you try to do it in the normal compiler, it will not work in case of errors, so it will still not drop any signatures if there's any errors, because it's not the presentation compiler. It cares about whether the file compiles. We can work around that. We can add options, but that would need to change the Scala 2 compiler a lot. And like ideally, we don't want to change the Scala 2 compiler a lot, but for any new approach, we would start with Scala 3 and maybe have that as an additional bonus to better experience, better tooling, better things for Scala in Scala 3.
If you only use a pickle format, can you then jump to definition or maybe find all usage, those kind of things?
No, I think we should be able. The pickles, I think, have some positions, or maybe I'm mistaken.
No.
But if you look at the current approach, actually, this one works if you go to. Oh, now it stopped working, but never mind. So this is needs to recompile every time, and I don't know why currently, but now it will go to food too. So definition, go to definition works. But that's not pickles, I guess. It's just. But I'm thinking that maybe if pickles don't have position, then go to definition will not work unless it is in semantic DB. But we could also.
Maybe the Y outline would work with the semantic DB plugin as well, or we can make it work. But that means you will have a separate semantic DB file somewhere that is different from the real one, but that is useful just for the partial completion.
Yeah, it could be, for example, like replace. So first we look at the early one, then we look at the full one. But yeah, semantic DB could be, we could try to do that early, but I don't know how much work that would be actually. And
yeah, I think it's worth trying because maybe it's not a lot of work to make. Maybe it already works, like the compiler compiles and semantic DB is edited. I don't know.
Yeah, maybe because this would also mean everything that depends on semantic DB would work correctly. So renames would be much better in that case. They would be able to work even in your broken code. But on the other hand, we could also try and work on renames as part of presentation compiler instead of using semantic DB in case of like local variables and things like that. But yeah. So there's a lot of things we can experiment with, and maybe I think like a lot of those we can experiment with in Scala free compiler, because if we put it under a flag, I don't think anybody will mind an experimental flag, hopefully. But yeah, a lot of things could go wrong. There's a lot of possibilities, but I was very happy that I managed to get the demo actually working in a bit.
Yeah, that's
although it's
pretty fun.
Not usable at all. It just like there's no caching. No, everything just gets compiled every time you try the completion. So don't do it at home.
Ship it.
Okay, so I hopefully it's not too short. I just wanted to throw it out there. If anybody finds or figures out any kind of what else we can do, or what I missed, please do let me know, and hopefully we can figure something out. Vadim will probably take a look at what we can do with Scala free and those early flags, and I'll try to figure something out maybe with Y outlines. And we'll touch points to see which approach is better and what we can.
In the Scala free, what is the data structure that you want the compiler to produce?
Well, ideally it would be signatures, because I think tasty cannot be produced early.
No, tasty is produced. It's just not actually written to a file until the backend. But it's
so maybe we could just drop it early, and tasty files could already be used.
Yeah, I think it's just not produced until the backend, just to make sure that all the checks after tasty are valid.
Drop tasty early. Flag.
I wonder if there'd be a way to make a, I don't know, streamlined tasty.
You want like a simpler tasty, or a...
like tasty without right-hand side.
So why outline tasty?
Outline tasty, yeah.
Yeah.
Could,
that would be
great. Could work.
The weird thing about the solution is that we would have this additional class files that you shouldn't use if you're not doing it from an IDE or a tool. So,
yeah, that's all right. We've we've got those in Scala.js land as well.
Okay. So there's what's it called? That already has been done. So no, we cannot do more harm.
Yeah.
But okay. Wildlife tasty.
Should we have a mode in the compiler that tries to compile everything, and if it fails, just emit the signatures?
Yeah, that would be.
Separate class files.
Yeah.
The difficulty is that for yeah.
Thing is,
There's probably lots of unknowns there.
But if it is only used by IDE, then what's the big deal?
And the
what do you mean?
phases assume that the prior phases have not emitted any error.
But there could be a marker to say if there was errors in the file. So it shouldn't be trusted if in a
Yeah, but what will you do? I mean, even if there is the compiler works with several files at once, and if there's an error in one file, it can mean a corrupt data structure for another file, even though that other file did not error earlier. It would introduce a lot of unknown fragility.
yeah, there's a lot of caches that would probably
Although,
stuff, right?
All sorts of stuff.
but best effort for an ID is still good. I feel like if we don't show something, it's okay. Sometimes if a code is broken, you cannot expect everything to work perfectly. I feel like.
Yeah,
But
'cause
it will
if
still
the
be
ID
better.
working, then the ID doesn't produce extra class files or whatever. Or
But yeah.
if you reuse the real compiler and the IDE's compiler and then they corrupt each other, that would be a problem.
Yeah.
But if they are sandboxed from each other, then would that be a problem?
Yeah, they should be sandboxed.
Oh yeah, but it will be sandboxed if we're using. There won't be if we're using BSP and SBT, right? Because it'll just be the same compiler.
Well, that would mean that we need an alternative mode of how BSP works that emits in the class files in a different place.
Yeah, that would need to be done via this flag. We could add a directory for that.
Yeah.
Metals could add it. Like if you fail, dump everything you know into this directory.
Yeah.
Yeah.
But what is funny is what I actually need here is the presentation compiler being done by Zinc, being invoked by Zinc, and working the same way a presentation compiler would work, but with Zinc.
Yay.
But I wonder how IntelliJ does it.
I mean, IntelliJ doesn't have the real compiler lying around anyway.
Yeah.
I mean, it has for the full compilation, it's completely separate, distinct from its presentation compiler.
It also uses, not for completion, so maybe I'm wrong, but it also uses diagnostic from the actual compiler.
It does.
Yeah, but that's still does not interfere with the compilation product. It's completely, it's two different worlds entirely. The UI merges back information coming from both, but that's the only place where where they interact. Before that, they're completely distinct.
They have like their own solutions for every completion, everything there. So yeah, I cannot really duplicate that, and I wouldn't want that. But yeah. Okay, so I think that's it from me. Thank you for listening.
Oh, sounds a lot of fun going
Yes.
forward.